going to be talking about multicollinearity and the problems that this issue might bring to the interpretation of our coefficients in a regression. So talking about multicollinearity, you should think about two kind of different cases. So the first one is when we have two or more covariates that are actually capturing exactly the same information, but just in a different way. What do I mean by that? For example, if you have this regression and you're measuring smoking as pack of cigarettes that someone smokes in a day or number of cigarettes that they smoke in a day. Clearly, they're measuring exactly the same thing, just in different units. You can also think about this when you're talking about measures like height or weight. You can measure them in inches or meters or feet, or in the case of weight, kilos, pounds, etc. You're clearly capturing exactly the same information, just in different units. In practical terms, when that happens, you can't run a regression with two perfectly collinear variables. What will happen is that R is actually going to drop one of those variables. But that is actually not really a big deal because, again, R knows that it can run the model like that, so it will just drop one. The problem arises when we have two covariates that are not perfectly collinear, but they are very, very highly correlated to each other. So let's look at an example. Here we have housing data from Iowa, and we're going to be looking at how different amenities or characteristics of a property actually affect the sales price. So imagine that we're looking at total number of rooms and also the living area of a house and how those two characteristics affect price. As you can probably have imagined, sales price actually has a positive correlation with number of rooms. So a house with more rooms, holding other things constant, most likely sells at a higher price. And the same thing with living area. A bigger house probably costs more money than a smaller house, holding, again, other things constant. However, if you think about these two covariates, number of rooms and living area, they're probably very highly correlated to each other. It's very hard to have a very large house with very few rooms. And at the same time, it's very strange, if not impossible, to have a lot of rooms in a very small house, right? So these two covariates are actually moving together in the same way, and for that same reason, it is actually very hard to separate the effect or the association that these two variables bring to the table. So for example, let's see here at this regression. So you can see I'm running sales price, meaning the price that a house sold, on the total number of rooms that the house has in the living area, and other characteristics such as garage, fireplace, and the size of the basement. As you can see here, the coefficient for total number of rooms is positive, which is something that we expected, and the same thing with living area is also positive. However, when we look at total number of rooms, this actually is not statistically significant, okay? That means that we can't reject the fact that there is no association between total number of rooms and sales price. This, however, seems kind of counterintuitive because we know that houses with more rooms probably sell at a higher price. The problem here is that in this regression, we're also including the size of the house, the living area, and that is also capturing already a lot of the association that total rooms and price have with each other, okay? So if you go to the code for week 3, you can actually run this same regression, but now exclude living area. What happens now to the coefficient of total rooms? Is it still statistically not significant, or now is it statistically significant? So again, the main problem with having two highly correlated covariates is that it's very difficult to separate the contribution of each of them, and because they move together, most likely, if they're very highly correlated, one of them is going to be just too noisy to actually detect an effect. What can we do about it then? Depending on the analysis that we're actually conducting, it might be a good idea to just exclude one of them. We don't need two variables that are capturing exactly the same thing. And if we want to actually get to the bottom of how an extra room, for instance, affects the sales price, then we should probably exclude living area because that's already being captured in that other variable. We could also create a new variable, like a variable that captures everything that is not being captured by living area, meaning the residual of that variation. Or we could also just aggregate variables. Think about linear combinations, or actually creating an index that kind of captures both variables, and just having now one characteristic that embodies both covariants. Either way, it's a problem that it's important to have in mind, and also don't take things at face value. Always look at your model, see what you're including and what you're excluding from it, and just proceed accordingly. Okay. If you have any questions about this, feel free to reach out, stop by office hours, or ask these questions in class.